Good morning, good afternoon, or good evening, depending upon where you live around the world. So, what have we got here? This was created within SketchUp probably a couple of years ago now, and I'd been wanting to create a sled for my bench saw with the end purpose in mind of being able to create multiple-sided joinery, or at least multiple-sided items. And for that you need to have specific angles, very accurate angles, and they need to be repeatable. That sprung to mind just the other day when I was mentioning about the need for accuracy within the dome structure that we are contemplating making. So I searched out this model, and I thought, with a few adaptations, this could be a very worthwhile part of the build procedure or tools for our dome. Now, a lot of the sliding or the gauges, miter gauges, are semicircular, and that works fine. I wanted to go down a different path and have a square drawing so that I can get printed or get machined through a joinery company that does CNC machining straight onto my plywood or my custom wood base. I'm not too sure what other people call it around the world, but the compressed sheet. In this model, it was, as you can see here, if we wanted a 36-sided item, we needed specific angles, and 30, 24. There was a project, which I can't even recall what it was for now, where we needed these options. So, in SketchUp, I created this model where, as we can see, we can go down to the accuracy of 1/10 of 1 degree. Each line indicates 1/10 of the 1 degree. So you could get within that small angular dimension. And you could use this as it was. You could put your stop along this axis here, rotate it to the specific angle as required by the dome design, lock it down, and you would have your correct position for your cuts. Or, and this is where I think it could be quite a good idea, within SketchUp, once you've got your model made of your dome and have all your angles achieved, so you can you know what they are for each strut, you could have a equivalent sled for your bench saw made up with holes located wherever you decided you wanted them. So let's say you wanted, say, 39.4 degrees. In this case, you'd come up here, this is 40 degrees here, 39.4, you'd just come up to this position here. Within SketchUp, mark it just like I have here, and have a position for the CNC machine to drill a hole. Or you can just come up here and, as I said, clamp your stops in position. Quite easy. So I think this is one way of achieving those degrees of accuracies, even though it is just a bit of landscaping after all. But by starting with as close to zero tolerance as possible, any amount of inbuilt inaccuracies that we bring to the party by our own hands, that becomes the tolerance for the project. Now, remembering that a lot of the accuracies that you'll achieve in the workshop, once you put them outside and weather takes a hold, there'll be expansion and contraction and warping and what have you, so the accuracy may drop back somewhat over time and over through the weathering. But being able to initially get everything set up as accurately as humanly possible with a home workshop, this could be a tool with which we can achieve some of that. Part of that was, if we were to use the steel hubs, we've got the central hub and the wings that radiate out from them, we need perhaps to get the steel plate cut at a specific angle. Now, by using a sled such as this, it would be very possible to create an angle cut on a piece of timber, 2 pieces, put a metal plate between those 2 pieces which have the specific angle cut on it that we want, and by running our angle grinder, our hand-held angle grinder, the blade could run against the timber. We score and cut the metal to the exact measurement, and we've got a very accurate metal piece for our hub. Equally, if we cut a accurate piece of timber, we could then use that as a template for a chop saw to set its angle, its miter stops up, so that you can now, not through the accuracy of the chop saw itself, but through the template or the wee timber piece that you've cut on this sled, you can set the chop saw up to that specific angle and again achieve your metal component. So this is one way at least of addressing one of those build questions. How do you build it accurately? The one question that I've still got to work through, or still have to work through, is where we have the radial positioning of the wings. Were we to build one of those hubs, as I keep on referring to, with the center metal hub with the wings to the sides. And I think an adaptation of this, you would be able to get CNC machined so that you could have the stops inbuilt to the position of the, say, the hexagon hub or the other hubs that require those very specific angles. So rather than trying to achieve some magic in rotating them into position, you get a template for each hub made up at a CNC shop. I think that would be wise, and the point I was considering the other night was that a lot of these domes will be different depending on the person who's designing them. So the ability to use some proprietary star plate or hub may not be what we wind up having to have for our dome if we're going to be making it at home. So having the capability of making accurate cuts or accurate jigs may be that we just need to go along to a joinery shop with a set of SketchUp drawings and see whether they can build the jig for us. I don't think the cost would be prohibitive. I can't give you that pricing, but in the scheme of things with the dome, don't you feel that that would be a valid method of going forward to get the highest quality dome that you can possibly achieve yourself? I do. So I'm not going to chase this one down too far, but because I'm probably going to go back to the central hub, this central circular steel or high pressure density plastic hub, initially at least, because I can see a method forward that will facilitate a nice looking hub without some of the complexities of those other hub designs. And that, of course, will be another video in the series. But that will be for a later date. I just wanted to touch the base with this idea so that should you want to, you think, oh, well, I could build one of these within SketchUp as well, and move forward just as this fella prattling on the YouTube videos is trying to indicate. Oh, well, it's food for thought. Okay, I'm going to leave you now. I'll see you later. I'll see you in the next video. Bye.